Again, in this question, they're asking us to make qualitative predictions about the sign of delta S. To do that, it's important to note that S values, or entropy values, are positive almost always. So if you take a glance through Appendix 4, you'll see that the vast majority of entropy values are positive numbers. That'll enable us to qualitatively predict the sign of delta S, whereas with delta H and delta G, we won't be able to do that. Another thing to think about as you look through these equations, whenever you're putting something together into a larger compound, as we see with reaction A and reaction B, we call those synthesis reactions. You're taking pieces of something and putting them together into a larger single compound on the product side of the equation. That means you're making something that has more order than the pieces that were there to begin with. So, for instance, in reaction A, you've got sodium and chlorine coming together to form sodium chloride. There's more order or less disorder when those elements are found together in sodium chloride. A relatively higher entropy is found when they're separated. That'll also be the case in reaction B. You have nitrogen and hydrogen floating around in solution separately, then they come together to form ammonia. There's more order or less disorder, lower entropy, in the product. In question C, we've got the opposite. You've got sodium chloride breaking apart to form sodium ions and chlorine ions. This is called a decomposition reaction, where you're taking something that is more ordered or lower entropy, less disorder, and breaking it into pieces where you've got a situation where there's more disorder, higher entropy. So if you can remember that entropy values are almost always positive, for the synthesis reactions we're taking a small positive number minus a bigger positive number. That gives us a negative result. That'll be the case for both A and B. A small positive number minus a bigger positive number, giving us a negative value for delta S. In question C, we have a high entropy value, bigger positive number, minus a smaller positive number. That'll give us a positive result. And then lastly, in part D, they're asking us to consider the melting of sodium chloride. It's going from the solid state to the liquid state. Well, as you might recall, solids are the most ordered state. Most ordered, which also means least disordered or lowest entropy. So when we consider this one, we've got a low entropy value for the solid state and a relatively higher entropy value for the liquid state. And remembering once again that entropy values are positive, you have a high or a big positive number minus a smaller positive number. That gives you a positive result. So the answers go negative, negative, positive, positive.